Hi, welcome back to my channel pibyme Maths. This is Devan. Here we are going to be looking at October 2021 Pure Math 3 paper. In part 1 of this video, we have covered question number 1 to 5. Let's look at question number 6. We have an equation of a curve given. Show that the curve has a stationary point when x is equal to this. So to find the stationary point, x coordinate of the stationary point, you have to differentiate it and equate it to 0. So how do we differentiate ln this? 3 ln x square minus 5. You keep 3 as it is and then treat this as x. So you have ln x. Derivative of ln x is 1 over x times. You need to differentiate the highlighted one, so you will get 2x. Minus derivative of 4x square is 8x, 15 becomes 0, is equal to 0. So you get 6x over x square minus 5 is equal to 8x. Bring this term here. So you will get 6x is equal to 8x times, or multiply throughout by 8x, 8x cube minus 5 eighths of 40x. Put everything on side and solve for x. So you will get 8x cube minus 46x is 0. Take x as a common factor. 8x square minus 46 is 0. So x is 0. That's one x coordinate of one of the stationary point. And then 8x square is 46. X square is 46 over 8, which is 23 over 4. So x is going to be plus or minus square root of 23 over square root of 4. But you need to respect the domain given. It says x is greater than 5. So you can ignore this, you can ignore the negative one. Therefore x is equal to square root of 23 over positive 2. It's a 4-mark question. Let's move on to double I now. A different curve has equation. They show that dy by dx is this. You need to differentiate it. When you differentiate it, 4x becomes 4 minus 12. We need to differentiate sine square using chain rule. Take it as x square. Derivative of x square is 2x and derivative of sine x is cos x. And we know the double angle formula for sine 2x is 2 sine x cos x. So you can write it as 4 minus 12 sine 2x. That's the gradient function dy by dx. That's the answer for part A. Part B, they want you to find the maximum value of this function. So sine 2x, the maximum of sine 2x is 1, minimum is minus 1. When you sub in both the value, 4 minus 12 times 1, you get minus 8. 4 minus 12 times minus 1, you will get 16. 16 is the maximum value. So 16 is the answer. Question number 7. The mass m kilogram of a species of tree can be modeled by this equation. Okay. Where r centimeter is the base radius of the tree. The base radius of a particular tree of this species is 45 centimeter. According to the model, find the mass actually. The radius is r is given, you need to find m. So you just need to sub in into the equation. So you'll get log m to the base 10 is equal to 1.93 log 45 to the base 10 plus 0.684, and you need to make m as a subject. So m is going to be 10 to the power this whole thing. So I'm going to calculate 1.93 times log. If you don't put the base, the default base is 10, log 45. Calculate this plus 0.684, 10 to the power 3.874, etc. Get the value and then round it to 2 significant figure. So 10 to the power answer they want the answer to two significant figures. So when you round it to two significant figure, you will get 7500. The unit is kilogram. That's the answer. Just a 2-mark question. Part B now, they want you to rewrite the equation in this form. The equation given is log m to the base 10 is equal to 1.93 log r to the base 10 plus 0.684, right? Yep. Okay. So what I'm going to do, I'm going to put a log 10 to the base 10 here. So every term has log in it. It's easy to get rid of logarithm. So now log m to the base 10 is equal to, you can put this using laws of logarithm, you can put this as a power here. So you will get log r power 1.93 plus log 10 power 0.684. And using laws of logarithm, you need to combine this. Log a plus log b is log a times b, and get rid of the logarithm both sides. You will get m is equal to r power 1.93 times 10 to the power 0.684. They want you to write it in this format, where they want the values of a and p and q to three significant figure. Q is r power q, it's already three significant figure. We need to find the value of this and change it to three significant figure. So it's 10 to the power 0.684. 4.83. So m is equal to 4.83 times r to the power 1.93. If you want, you can write p and q separately. P is this, q is this. That's all. Okay, now we have m is equal to p r power q. Part C says, with reference to the model, interpret the value of p. You need to find out when do you get with the value m is equal to p. If you replace r by 1, you cannot replace q by 0 because q is not the variable here. The variable is r. When you replace r by 1, 1 power q is just 1, you will get m is equal to p. So you need to change it to a sentence related to the context given. So you cannot just write when r is equal to 1, m is equal to p. You will lose more. You need to write P is basically the mass of a tree with radius 1 centimeter. So you need to write P is the mass of a tree with radius 1 centimeter. Question number 8, part A, sketching inverse trigonometric function. Okay, draw the axis, always label the axis on the origin. This is basically the arc sin x. With this value pi over 2 minus 1, 1 minus pi over 2. This is basically arc sin x. But if you replace x by half x, it's a stretching along x-axis, vertical stretch. So you need to multiply the x coordinates by 2. So the y coordinate stays the same. The new x coordinates would be minus 2 to 2 now. So this stays the same, pi over 2, this stays the same, minus pi over 2. And then label the graph. Y is equal to arc sine or sine inverse of half x. It's just a 1-mark question actually. Let's move on to part B. You have a function given x is equal to sine 2y. They want you to write dy by dx in this format. Differentiate with respect to y. Derivative of sine y is cos y. Now flip both sides. Dy over dx is equal to 1 over 2 cos y. But they don't want in terms of y, they want in terms of x actually. That's when we need to use the original function. X is 2 sine y. So sine y is going to be x over 2. We know cos square plus sine square is 1. So cos square is going to be 1 minus sine square using trigonometric identities, which is x over 2 whole square. So cos y is going to be square root of 1 minus x square over 2 square, or you can put it as a single fraction, 1 minus x, 4 minus x square by 4. So sub in here is going to be 1 over 2 times square root of 1 minus x square by square root of 4. You cancel this, square root of 4 minus x square. So the answer is 1 over square root of 4 minus x square. So 3 more questions. Part C now. Find the equation of the tangent at P. P has a y coordinate pi over 4. The function is 2 sine y. So when you replace y by pi over 4, x is going to be 2 sine pi over 4. Sine pi over 4 is 1 over root 2, 2 over root 2 is root 2. So the point is root 2 comma pi over 4. And then we need the slope. We have dy over dx, which is 1 over square root of 4 minus x square. So the slope is equal to dy over dx at p of root 2 comma pi over 4. So in dy by dx, replace x by square root of 2 here. Square root of 2 whole square is 2, 4 minus 2 is 2. So 1 over root 2. That's the slope of the tangent. So you can write the equation y minus y1 is equal to slope times x minus x1. So y is going to be 1 over root 2x. When you multiply these two, you'll get minus 1. Bring the minus pi over 4 here, plus pi over 4. That's a solution. Do not change anything to decimal. Question number 9 now. We have a graph given. Figure 3 shows sketch of part of the curve with f of x is this. Find f dash of x. Okay. You can write f of x as multiply through it by x. You will get x cube minus 4x times e to the power minus half x and apply product rule. Take the first one as u, x cube minus 4x as u. The derivative of u is 3x square minus 4. Take v as e power minus half x. Derivative of v will be minus half e power minus half x. Now let's apply the product rule now. vu dash, which is 3x square minus 4 times e power minus half x plus uv dash, that is a minus, so minus half e power minus half x times x cube minus 4x. It's just a 2 mark question, so you don't have to simplify, take out the common factor, and I'll leave it as it is. Now part B says the line L is the normal to the curve at O. Okay, the O is the origin 0, 0. And the normal meets the curve again at point P. The point P lies in the third quadrant. If it lies in the 1 to 3rd quadrant, both x and y will be negative. Show that the x coordinate is a solution to this equation. Okay. We have f dash of x here. To find the slope of the tangent at origin, you replace x by 0 here. So when you replace x by 0, this is 0 minus 4 e power 0 is 1 times 1 minus half e power 0 is 1. This is 0 minus 0, everything becomes 0. You will get just minus 4. So the slope of the tangent is minus 4. Therefore, the slope of the normal will be negative reciprocal, 1 over 4. And the line normal passes through this point. So y minus y1 is equal to slope times x minus x1. You get the equation y is equal to 1 over 4x. Now replace y by the original function given here, this one. X times x square minus 4 times e power minus half x is 1 over 4x. You can cancel this x first. Bring e power minus half to the other side. You will get x square minus 4 is 1 divided by 4 e power minus half x, or bring it to the top, e power positive half x divided by 4. Bring the minus 4 this side, you will get x square is equal to e to the power half x divided by 4 plus 4. Put it as a single fraction, 16 plus e power half x divided by 4, that's x square. Wait, are we missing something here? No. Now x will be plus or minus square root of this. Since the question says x coordinate p is in the third quadrant, x is going to be minus square root of 16 plus e to the power half x by 4. But we know square root of 4 is 2, so you put it as minus 1 over 2 square root of 16 plus e to the power half x. That's all. It's a 4-mark question. Let's move on to next one. They want you to use this as a iterative formula with the initial value minus 2 and find x2, and by using continuous iteration you need to find the x coordinate of p to 4 decimal place. It's a 3-mark question, so you need to write a step actually. So I'm going to write x2 is equal to minus 1 over 2 square root of 16 plus e to the power half times x1. x1 is minus 2 minus 0.5 square root of 16 plus e to the power half times minus 2. So when you round it to 4 decimal place, 0.229 minus 2.0229, that's the value of x2. So you'll be given 2 marks for this. Now by continuous iteration you need to find the x coordinate of p to 4 decimal place. So I'm going to bring the cursor to where we inserted x1, delete it and press answer. So the new answer will be the latest input here. Now all I need to do is just keep on pressing the equal and look at the decimal points. 226, it got stuck at 226. So minus 2.0226 is the answer. Question number 10. Now we have a figure given. Figure 4 shows a sketch of part of the curve with the equation. They show that this can be rewritten in this form. So what I'm going to do, I'm going to write 1 plus 2 cos 2x whole square. I'm going to expand it. A plus b whole square is a square plus 2ab plus b square. That's the first thing you need to do, expand it. And then we know this double angle formula, cos 2x is 2 cos square x minus 1. If you rearrange and make cos square x as a subject, you will get 1 plus cos 2x divided by 2. But we need cos square 2x, not cos square x. So I'm going to replace x by 2x on both sides of this equation. So I will get cos square 2x is equal to 1 plus cos 2 times 2x, which is 4x by 2. Sub in here. The first two terms, right, keep it as it is. 4 times 1 plus cos 4x over 2. Cancel this, you will get 2. Open the bracket and simplify. You will get 2 plus 1 is 3 plus 4 cos 2x plus 2 cos 4x. That's all. Part B. The curve touches positive x-axis for the second time when x is equal to a. As you can see from the figure, it touches second time when x is equal to a. On the shaded region bounded by all this, they want you to find the exact total area of the shaded region. So we are going to integrate the curve from 0 to a. But we need to know the value of a. That's the x-intercept. To find the value of a, we take the curve, replace y by 0. That's how we get the x-intercept. So you will get 1 plus 2 cos 2x is equal to whole square is 0. Make cos 2x as a subject. So take square root both side and make cos 2x as a subject, you will get minus half. You need to solve this trigonometric equation and take the second solution. The method I teach is you need to find cos inverse of positive half. So you use radian mode. Cos inverse of positive half is pi over 3. 2x is equal to pi over 3. Cos inverse of positive. That's a principal value. That's not the solution. And then you use a STC diagram. Cos will be negative here and here. This is pi minus pi over 3 principal value. This is pi plus pi over 3. So you need to take the second solution. So 2x is equal to pi plus pi over 3, which is 4 pi over 3. Divide by 2, you will get x is equal to 2 pi over 3. That's a lot of working to find the x-intercept. If you know any shortcut, just use it. So now comes to integration. Now we need to integrate the curve from 0 to 2 pi over 3. So the area is equal to integral 0 to 2 pi over 3. Instead of integrating this function, we are going to integrate this. That means this. 3 plus 4 cos 2x. 3 plus 4 cos 2x plus 2 cos 4x dx. Integral of 3 is 3x. Integral of 4 cos 2x is sin 2x by 2. 2, 4 can be cancelled. You will get 2 sin 2x. Integral of cos 4x is sin 4x by 4. 2 and 4 you cancel. You will get sin 4x over 2. 0 to 2 pi over 3. And we need to carefully simplify this and get the answer in the exact format. First, I'm going to sub in the upper limit now. When I sub in the upper limit, 3 times this, when you sub in here, 3 will be cancelled, you will get 2 pi. And then sin 2x. Sin 2x is going to be 4 pi over 3. 2x is 4 pi over 3. Is minus root 3 over 2. And I have 2 times minus root 3 over 2 plus 4x. So it becomes 8 pi over 3. It is root 3 over 2. So 1 over 2 times root 3 over 2. That's upper limit minus. Lower limit, sin 0 is 0. Everything is 0. So I have 2 pi. Here 2 will be cancelled, minus root 3 plus root 3 over 4. So when you simplify these two like terms, minus 4 plus 1 minus 3 over 4, you will get 2 pi minus 3 over 4 root 3 as the answer. That's all.